Alright, so we're going to do a potential energy of a spring question. This is from Mastering Physics, question 10.18, if anybody is doing that problem. So the question is, how far must you stretch a spring with K equal to 1200 Newton meters to store 150 joules of energy? It's always good to write down your knowns. So, where would you start with this? You'd need to know what the equation for the potential energy of a spring is, and most likely you'll be given that. If you're not, we'll go ahead and set it equal like this. U, which is the potential energy spring, is equal to 1/2 times K times x squared. K was your spring constant, and x is your distance that you can press the spring. Now we're going to go ahead and get rid of this little bit right here, so we have room to solve the problem. 1/2, by the way, just kind of comes from a derivation that we won't do in this video. So what is our known? We'll go ahead and say our known is 150 joules for the potential energy right there is equal to 1/2, just a number from the derivation, times K is that one, which is equal to 1200. Let's go ahead and write in the units here just to justify them. And then that is going to be times some x, which is what we're solving for, squared. X has the unit of meters, so we're going to be able to cancel out one of these meters and still be left with a meter. Alright, so then we're going to go ahead and solve this. You get 150 joules equals 1/2 of 1200 times x squared. So this will go ahead and cancel out to 600. We won't hold on to the units anymore, not necessary. Go to your calculator, and we're just going to divide the 600 over to there. Since it's multiplied by the x squared, you're going to get 150 divided by 600, which is 0.25 equals x squared. Get rid of the squared. You're going to take the square root of both sides, plug that into your calculator, and you will get 0.5 meters is what we are in, because we're figuring out how far we'll have to compress it, equals x. And that is your final answer.